So just a bit of a recap because we're doing something pretty significant as we move into the next section here. So far we've talked about factoring expressions. So we have expressions in math, and expressions are, a sensible thing, but there's no equal to sign in it. So we are now going to move into equations. So just like I said, as a review, expressions can be simplified. They might be evaluated. They could be factored, which is a key thing that we've been doing so far, but they cannot be solved. And so equations can actually be solved. So they can tell you what x equals, right? And we need to have an equal to sign so we can actually solve these things. Now, we are going to keep going with factoring because factoring is a way of getting to the answers in a quadratic equation. And so quadratics, like I was saying before, we have an x squared term. This is the standard form of our quadratics. You can see the a and the c and the b term that we talked about with the AC test. And they are always going to be set equal to 0. And that is important because we are going to use a few key things in solving these things. The other thing to recognize in this form is that we have these in descending order. So the terms are x squared, x, and then whole number. That's important. And like I said, we also have the equal to sign. Okay, so the strategies in solving quadratic equations is that we're going to factor them, and we can factor them with 3 different ways. So greatest common factor, the AC test, and the difference of squares. So at the end of last section, hopefully you've had some time to brush up on your skills here. This is going to be hard if you're still a bit rusty in the processes of greatest common factor, the AC test when you see 3 terms, and the difference of squares when you see 2 terms, right? After we have it factored, we're going to use the zero product principle. And you don't have the benefit of seeing me right now. I always do this weird thing. It sounds like what a robot would say. So the zero product principle. Basically, once we get it into factored form, you have options. If either of your factors are 0, then the equation's going to be true. I think that's easier to see in practice. So let's start with one of these examples. So this example that's over here, I'm just going to highlight some things in orange, is a quadratic equation. It's in descending order. It's set equal to 0. If I were to factor this, I would factor it with the AC test, right? There's no greatest common factor. I would have negative 18 at the top of my number puzzle. 1 and 18, 2 and 9, 3 and 6. They would have to add together to give me my negative B term, or my negative 3. Those are going to be the 2 numbers that actually satisfy my AC test. They satisfy my number puzzle. And so now that I have this in factored form, I have my 2 binomials. Either this could equal 0 or this could equal 0. So this is where you get the either or bits in my answer. This is the zero product principle in action. So basically what I'm going to do is solve each one of these to give me 2 options for x. And this is totally getting ahead of myself here. The reason that we have 2 options, I scribbled this in an earlier bit of the work, is that these graphed are going to make shapes like that. So these 2 points here are actually where the parabola is going to touch that x axis on my coordinate plane. And so, again, getting ahead of ourselves, It's not until D6 that we actually graph these things. But that's why we're getting options. So this either or bit of the zero product principle is kind of weird because now you have two correct answers for these quadratic equations. So again, with these, what we're going to do is factor and apply the zero product principle. So in this one, I have this in descending order. It's set equal to 0. I have plus 20 at the top of my number puzzle. It's a positive 20, and I want, whoops, that's not a 9. That would be a 5. And I want to add together to give me a negative 9. So these are the two numbers that would complete my binomial factors. It's significant that it's still equal to 0 because now I can do my zero product principle. I'd say that either x minus 4 equals 0, right? This first bracket equals 0, or if the second bracket equaled 0, I would have this equation be true. And so in both of these, it's the easiest algebra that we ever used to do. X could equal 4, or x could equal 5. And we do literally have two options for these because these are the two values where it would, where the shape would cross the x-axis. And again, getting ahead of ourselves, but sometimes that context is important. The other thing that you could do here, and I'm not going to do it, believe it or not, you could check. You could verify left side, right side, subbing these in times 2, right? Because you have two different values of x that you could check, and both of them should check out. So just as a bit of an aside, obviously not enough space on this page to do all that, but that's what we're working with here in solving these. So for B, when I take a look at this, I've got two terms. It's not a difference of squares, but there is a greatest common factor here. I could factor an x out of both of these and write what's left over in the brackets. And so now when I apply my zero product principle, either x equals 0 or x minus 5 equals 0. So x minus 0 is done. I don't have to do anything with that one. But this one, I'm going to finish solving for x and get that x equals 5. So again, two options on these, either x equals 0 or x equals 5. So assuming that your factoring is pretty decent, for C, when I take a look at this, I don't have three terms, so I'm not going to do the AC test. I don't see a greatest common factor, but what I do see is a difference of squares. So using my difference of squares pattern, I would factor my quadratic. And now that I have it factored, I apply the zero product principle. Again, sounds like a robot. I always make this weird gesture. You can't see like robot arms. I'm doing it right now. So either x plus 3 equals 0 or x minus 3 equals 0. So x equals negative 3 or x equals positive 3. Last one here. I have three terms. It's not a difference of squares. There isn't a greatest common factor. Those are all my thought processes. I'm going to have to do the AC test on this. I'd have plus 9 at the top of my number puzzle. I'd factor 9 in as many ways as possible. Oh, look at all these lovely positive numbers. Those are always the easiest. I would factor this. I would apply the zero product principle, either x plus 3 equals 0 or, oh, same, right? X plus 3 equals 0, minus 3 from both sides. I only get one answer. This is a bit of an oddball in the world of quadratics, which we won't have to graph at any time, but you only get one option for this really special kind of quadratic. We still solved it in the same process where we factored it, and then we applied, my robot arms are coming out, the zero product principle. The last two on the page have one extra little wrinkle to them in that they are not set equal to 0. So you can't do the three product principle. You have to do the zero product principle. And so in order to get these solved, we have to actually rearrange first. So if I were to subtract 3 on both sides, I would get this set equal to 0. Now that I have this set equal to 0, now I can factor it and then apply the zero product principle. So -3 would be at the top of my number puzzle. 1 and 3 are my only options. I'd have a +1 and a -3 that add together to give me my -2. So factoring this, I get x plus 1 and x minus 3. It's still set equal to 0, which is significant, so that I can do my zero product principle. So either x plus 1 equals 0 or x minus 3 equals 0. In solving these, I'd subtract 1 on both sides. I get that x equals -1, or you might be dropping, showing your work at this point. X equals 3. Last one to do, we have to make it set equal to 0 first, so I would add 3 to both sides. I would factor this, then apply the zero product principle. So there's no greatest common factor. It is not a difference of squares. I'm going to try the AC test. I'd have 9 at the top of my number puzzle. I'd have 1 and 9 or 3 and 3. -3's would add together to give me that -6, which is my B term. So that gives me the numbers that are in my binomial factors. And I would then apply the zero product principle. Either x minus 3 equals 0 or, whoops, the same. So this is like the one above. We only have one option, weirdly here. X equals a 3. Definitely take some practice at any point. If you need more practice, talk to your instructor and make sure that you're getting some extra support as you learn the factoring skills and then how to solve by factoring.